Hey guys, back just doing a quick review on merge sort. If you want to see me actually code it and go into a little bit of the theory, a little bit more than I will here, you can go watch the previous video. Otherwise, I am just going to go over the code one more time and talk about what it's doing and everything. This is going to be a really quick video. Okay, so just three functions: merge, sort, and print list. Print list is just the same as always, just going to print out the list for us. The main's pretty simple. I'm just going to make an array, print the list, sort it, print it out. Let's get into the actual algorithm. It's not wasting more time. So for the sorting part, remember with merge sort, we're going to keep making it and splitting it into smaller and smaller and smaller and smaller lists until we get list of size ones, because we know they're sorted, and then we'll start combining those tiny little lists together. Okay? And since we've sorted really small parts of the array, and when we merge them, it'll go way faster. We don't have to go grab somebody from the far end or from the far other end and start moving them through or making a billion comparisons when we move someone all the way up and then checking all the way back like insertion sort. No, all we have to do is merge individually people, and then as we grow bigger and bigger and bigger, we'll have at the end, two perfectly sorted arrays that we can just keep comparing the start guys and just picking them as we need to form a sorted list. Merge sort's great for getting like almost the same time, pretty much the same time. Every time you run it, it's going to get the same time. As long as you keep your arrays the same size. Doesn't matter if you switch the values, merge sort's on point on that. But you have to use a little bit more memory because you have to make a secondary array that you store your guys you're sorting and then rewrite the original. So what I'm going to do here is when low is less than high, we know we're not down to a size of array 1 yet, because if low is less than high, we know we have different indices, meaning we have more than one element. So I'm just going to return, I'm going to come in here, I'm going to get a middle ground, I'm going to low plus high divided by 2, and then I'm going to split him by just going nums low mid, and then mid plus 1 high. And the mid plus 1 is because if you do the math in your head, say I have a list of 5 guys, the mid's 2.5, but I'll round down to 2 with integer division, so we'll get 0, 1, 2, and we want to make 3, 4 their own indices. So for the first guy, basically, if that was the case, I'd put 0 and mid, which is 2, so 0, 1, 2, on my own little split over there. Don't worry if it's odd or even. And then over here, I'll get 4 and 5, because I'll add 1 to mid, so I'll start at, or 3, 4, and 5. I'll get 0, 1, 2, and then 3, and 4, sorry. I'll add 1 to mid, it'll become 3, and I'll get 3 and 4, because high was my 4th index, okay? So that's great. So I'll just keep going down and down and down, keep splitting it, splitting it, splitting it. As soon as it goes both ways, where it divides down by the middle and comes back up, say it hits like a 0 and 1 index, the middle is now 0. So if I put in 0 and 0, I'll get an instant return. And now if I do it the other way and I add 1 to mid and I go down, I get 1 and 1, which is not, low is not less than high, so it'll pop back up. So I know I'm at a size 2, right? And I'll just compare those guys and sort them, which you see here with merge. So I put in the low, the middle, and the high. That's important because as we get to the bigger arrays, there'll be big ranges of numbers, right? All stored in an array. And we know that 2 sections are sorted, right? Not the entire thing. And not even relative to each other. One could be like 7, 19, 21. The other could be like 3, 4, 12, you know. In the bigger picture, these aren't sorted overall, but in their tiny sections they are. So we want to know the middle between them so we can be comparing each array and get the smallest guy from whatever array. Okay, if I take the smallest guy from whatever array, after comparing them, you know, I will end up with a fully sorted array. I'm merging the arrays together. So let's go to merge and look at that. So I'm going to get L1, L2. They're just list 1 and list 2 respectively. It's the start of the first section and the start of the second section. Then L2 starts at the middle plus 1 because of how we've been splitting them. L1 starts at low, the start of the overall range that we're combining. While an I is going to be, we have to make another array, and whatever range we're sorting in A is going to be the exact same size as A, right? The first array, or nums in this case. And the range of nums that we're sorting, we're also going to store in the range of those indices in B as well. So I'm going to say I is equal to low. So I start at the same point, the lowest point in both A and B. So I'm sorting them exactly. That way I don't hit like the end of B before I'm done sorting and get a bunch of junk going on. So while I is less than or equal to high, so as long as it hasn't reached over the end of our range, we know we still have people to be putting in our section in the right order. So if L1 is greater than mid, we know we've exhausted everybody in the first list. Say I had two lists, 1, 2, 3, 4, 5, 6. Well, we're obviously going to take 1, 2, 3 first, and there's going to be no more of list 1. In that case, we literally just grab 4, 5, 6 and put them in, and that's what we're doing here. I'm saying just B is equal to nums L2 now, and just keep putting them in there. And you see this plus plus activates after the expression. So it's as if I had this here, and afterwards did I plus plus, L2 plus plus. But instead, just to save a little bit of space, I just put it in here. So it's really saying B of I is equal to nums L2, and then I'm just adding one to it. Another video guide done rendering. I just add to it to continue on, because now that we've put someone in B, we're on to the next part of B. And now in that section, since we've taken the lowest guy, we've got to move on to the next number in there. The same goes over here. If L2 is bigger than high, I know I've exhausted my second list, and I'm just going to start plunking from the first list. If neither of those are the cases, I know I still have to compare wherever I'm at in either list together. So if nums L1 is greater than nums L2, I'm going to take L2 because he's the smallest guy. BI plus plus is equal to nums L2. I know what the smallest guy in either of the lists, when I compare them, the smallest of those two has got to be the smallest overall. I'm just going to do the same deal where I'm incrementing them. If otherwise this isn't true up here and the other lists aren't exhausted, I know that L1 is really the smallest, wherever that's pointing, the smallest value, and I'll just put that in B. Now when all is said and done, I'm going to go back and overwrite that section of A with the sorted part. And you'll see that here for I is equal to low, I is less than or equal to high, I plus plus, nums I is equal to BI. Just going to overwrite it. And that's merge sort. Pretty straightforward. Not too difficult, my favorite sorting algorithm, and he's a consistent mofo, that is for sure. Now if we give it a run, I'm actually running quick sort over here because you gotta click on it. Merge sort code along. Oop, I got an error in here somewhere, which is weird. Must have been when I was changing things. What's it say? B undeclared. Oh yeah, I accidentally deleted B. B 20. Accidentally deleted B because I thought it was in another code thing, and I was like, what is this element? And boom, we have it perfectly sorted. Okay, great. So that's it overall. Great, reliable sorting algorithm. I hope this review helped you. If you want a little bit more in depth of seeing the process of coding it, and you see me running a couple errors. So if you want to, actually, I don't think I ran any errors while coding this one while filming. That was awesome. Yeah, so that's it for this. I hope you learned something. I hope it helps you better understand it. I'll see you next time.